Hello, we're going to do some translations on the coordinate plane. We're going to use coordinate notation to describe them, perform them, and we're going to use vector notation to describe them and perform them. So a translation, if you remember, is just a slide in the coordinate plane. It's an isometry, meaning that it doesn't change it's the object's shape or size after it happens. So this is simply just going to slide it in the plane. Okay, so I'm gonna do a translation real quick, and then I'll say, well, how can we describe that? So let's say I want to translate this image or this pre-image up 3 and right 2. So I want to go up 3. Up 3 and right 2. So that's kind of how you would describe the translation if you were just kind of without any kind of special wording. Okay, so we're going to translate. So we're going to go up 3. We're going to take each point and translate it. And so we're going to take the vertices of the triangle, then we'll connect the new vertices, and that'll be the translated triangle. So I'm going to translate up 3, 1, 2, 3 over 2. And I get the coordinates. This is B prime, okay? B prime, because now we're talking about the image of B. So that went up 3 and right 2. So that went to 0. Let's see, the new coordinates are 0, 7. All right, 0, 7. Now the next one, A, we're going to go up 3, 1, 2, 3, right 2. There we go. And there's my A prime. And this is at -4, -1. All right, and then we're going to go up 3, 1, 2, 3. And right 2, 1, 2, and we're now at the point 8, -1. So that's C prime at 8, -1. All right, now we're going to connect those all up, and that's going to make the new shape. So we're going to connect these up like that. Well, thank you very much. We're going to connect those up, and now we have a exact copy of the triangle. This is now called the image. Okay, remember the after the translation is called the image, and the blue is called the pre-image. That's called the pre-image. Okay, now what we're going to do in this situation is we have to describe that. And we've come up with a couple ways to describe it depending on what kind of flavor you're going for. The first one is coordinate notation. So I'll go to black. Coordinate notation means that how did each XY coordinate change? So coordinate notation always starts out with XY changing to, so this means XY changes to, all right? And now I have to look at what happened to all of the X coordinates. So since I moved right 2, that's what affected the X coordinates. So if I look at A prime, or A, that used to have an X coordinate of -6. Now it has a -4. So how did I get from there to there? Well, I think I added 2. Let's see if that worked up here. -2 changed to 0. So that's adding 2. So that means that all of my X's had a 2 added to them. And then if I go to my Y's, we had to translate up 3. So you can maybe think about what is that going to do to all my Y coordinates? If you're iffy on it, you can look at the Y coordinates and say, here's my pre-image A, here's this. So we went from -4 to -1. That's an up 3 situation. So that's a +3. And then I went from 4 up to 7. Oh, that's a +3. And let's try C as well. We went from -4 to -1. That's +3. So that means that my Y, oops, not 2. My Y is a Y +3. Come on, folks. There we go. Now it's going. All right. Back. Y +3. All right. that. So that's called coordinate notation. It always starts with this XY changes to, so XY, and then we use this symbol to mean changes to. So an arrow, actually butchered that in the middle while I'm trying to fix it. Let's try again. Make a nice arrow. There we go, changes to that. So that's coordinate notation. Physics and math has another way to describe motion. They have what they call vectors. And a vector communicates how something moves. All right? So for instance, this vector right here, it looks like a ray, but the vector that moves from C to C prime on each one, okay, we notice it went up 3 over 2 on each one, up 3 over 2. So the vector looks like this. Okay? So then we have to show the direction of the vector. So we put the head of the arrow on one of them. So that right there is a vector. Notice that that tells us where to start. No matter where you start, you're going to go up 3 and over 2, or you're going to just follow along that vector. So if you grab that vector, let's see if it'll let me do that. Nope, it's not going to let me do that. Okay. That vector there is going to, I could redraw that vector at any point, at any pre-image point, up 3 over 2, and the vector takes me to the image, up 3 over 2. Notice this is the same vector each time, up 3 over 2. So this vector is just something that shows us motion, okay? Now, if I gave this vector, let's say I say this is P on this end, and let's say that's Q up there, we could name this vector PQ, and then to tell everybody it's a vector, you put this little half arrow on the top. That's vector PQ. Okay, so they might say translate, they'll say, here's vector PQ, and then make a translation based on that. Translate this pre-image ABC or ABCD to using this vector. Now, the other way we can describe vectors is its component form. Okay, so vectors have a picture. Okay, so it looks like this. A name, PQ, with a little arrow above it. And they also have what we call component form. And component form is simply, it tells you, it breaks the motion down into horizontal distance and vertical distance. So this vector takes everything and moves it horizontally 2 units. So component form always has these pointy parentheses, and the horizontal movement is 2, and the vertical movement is 3. So that's a vector right there, okay? So that's the component form of vector PQ. The picture is there. The picture had to be scaled correctly, so it has to be up in this area. Okay, I have to draw it somewhere where it works. So there's a vector, okay? So now we know how to translate, okay? We know what a translation is. We know how to slide something up 3, right 2. We know how to describe it with coordinate notation, and we know how to describe it with a vector, okay? So now let's move on. I'm going to erase, I'm going to try to get rid of everything, and we're going to just use those. So we know how to describe it now with coordinate notation and vectors. Now we're going to actually perform a translation using coordinate notation. We're going to kind of interpret what it says. So we're kind of waiting right now for it. There we go. Now it's ready. Okay. So we're going to translate triangle ABC by vector 4, -3. 4, -3. Okay, so I gave you the by vector 4, -3. I gave you the component form of the vector. I didn't give you the picture of the vector. I didn't give you the name of the vector. We're just giving you the vector, or the coordinate for the component form of the vector. So remember, a vector, its horizontal distance and its vertical distance are separated up. So if you combine those two, you get the vector. So if I wanted to draw the picture of that vector, I would start at one spot and I would move 4 horizontally, 1, 2, 3, 4, and down 3. And this is a picture of that vector. And if I wanted to, I could give these labels. Let's say this is M and N. Notice this would be M, N with the vector symbol. That's good. Now, if I wanted to go backwards, if I wanted to undo that vector, I would want to go exactly the opposite direction. I want to go -4, +3. That would undo vector MN. In fact, that would be called vector NM. That would undo the vector MN. All right, so kind of slide it back to its original. So now, I wonder what that would do here. Let's see. Let's go right 4, 1, 2, 3, 4, and down 2, 3, right there. Here's where B prime is. And then I'm going to go A, 1, 2, 3, 4, and down 3. And that's where A prime is. Then if I go right 1, 2, 3, 4, down 3, right there. And that's where C prime is, right there. So now if I draw that in, right there, there is the image of the translation by the vector 4, -3. So there's the vector. Well, let's describe that real quick. If I move horizontally 4, that means in my coordinate notation, that means that I had to add 4 to my x. And if I wanted to move down 3, that means I had to subtract 3 from my y. So that's coordinate notation of that vector. So there's coordinate notation for the vector for a translation.